Good afternoon, folks. This time around, we're going to discuss about work energy and power under mechanics option in mathematics. And by the end of this discussion, I hope we'll be able to define and calculate work also using formulae of kinetic and gravitational potential energy, application of principles of conservation of energy, and also solve motion problems involving changes in energy, define power as rate of doing work, calculate power using work done, time taken, force, and velocity, and also interpret real-life mechanical situations involving work, energy, and power. Now, we want to look at a bit of formula here. The first one is to calculate work done. W is equal to F S cos theta, and kinetic energy, that's half mv squared. Then moving on, we have gravitational potential energy, which is called mgh. Then power is rated which work is done, so work done per unit time, which is also equal to force times velocity. And for all these calculations, we take our g to be 10. Let's have a look at this part where we are saying power is force times velocity. Where does that come from? We said work is force times displacement. But now, when we bring power, we are saying we are dividing this by t. So focusing on this part here, it's just the same as F times velocity, because velocity is displacement over time. So power is the same as force times velocity. But let's also have a look at different thinking to say if I look at a change in kinetic energy, which I believe is also work done, change in kinetic energy is equal to initial or its final kinetic energy, which is half mv squared for final velocity. So it's half mv squared minus half mu squared for initial velocity. But if we check, there are common things that we can factor there, half m into v squared minus u squared. But according to equations of motion, it's a formula which says v squared equal to u squared plus 2as, such that if I make v squared minus u squared subject there, that will be equal to 2as. So if I come back to this part where I'm saying half m, inside the brackets is just the same as 2as. Then as I proceed with my simplifications, these two can cancel. So I end up having MAS. But remember, according to second law, F net is MA. Therefore, MA is the same as F. So I'm allowed to come here and say this is the same as Fs. But F times S, we said this is work. So work done is the same as change in kinetic energy. I hope this introduction was informative. I will meet in our further discussion as we solve those 10 examples to come. Thank you, folks.